Okay, so we're going to talk about some angle pairs that are created when we draw. Well, let's just start from the beginning. We won't talk about the whole thing, and we'll develop it as we go. So we have two sets of lines. They can be parallel or they don't have to be parallel. So let's just use parallel lines in the beginning, but it doesn't matter. So we're going to start off by defining a few things. We're going to say anything between, so between these two lines, we'll call this line L and this line M. Anything between the two lines will be called, is going to be our interior, that's our inside. Anything outside the lines, that'll be our outside lines, or instead of outside, we're going to use the word exterior. Then we're going to draw a line that goes across the two lines. Okay, now we could call it an across line or something like that, but there's a word for it that they use instead. We're going to call this T, and the reason we're going to call it T for now is because that's the same letter that the word describing this starts with. So the word trans, or the prefix trans, means across. So this line goes across, and so it's called a transversal. Okay, so a transversal in geometry is a line that passes across two or more lines. Quite often, or most of the time, maybe you'll see it with parallel lines, and that's why I wanted to draw these. But it doesn't always have to. They don't always have to be parallel lines for it to be a transversal. They can be non-parallel lines. So here's two lines that are moving along. This is still the interior, it's still in between. This would still be a transversal. Okay, so we have exterior on the outside, interior on the inside, and when you draw this transversal going across these lines, you get sets of angles that are created. So I'm going to number the angles: 1, 2, 3, 4, 5, 6, 7, 8. We could do the same thing: 1, 2, 3, 4, 5, 6, 7. There's 8 different angles that are created when we have two of the lines. If we had another set of lines, we would have 4 more. For every line that it crosses, you get 4 more angles. Okay. Now, the way we're going to do this, it's easier, if you're talking about with two lines, because it's easier to see. That's outside and that's inside. A little less confusing. So there are 5 different types of angle pairs that we're going to be looking at. And I'll start with the ones that I think make the most sense first. So if we look at angle 3 and angle 5, for instance. Okay, so angle 3 and angle 5 are both interior angles, right? They're both on the inside, they're angles, so that makes them both interior angles. Okay, so that's one thing. The second thing is they're on the left side, but we don't really care about left or right. What we care about is they're on the same side. Both are on the same of the transversal. Like that. Same side of the transversal. Okay? That makes them, we're going to write same side. Now they're interior angles, right? So they're on the same side of the transversal, same side, interior angles. Okay? So that's angle 3 and angle 5. Now notice they're not the only ones that are interior angles and on the same side of the transversal. 4 and 6 are also on the same side of the transversal. They're both on the right side, and they're both inside. They're all both in between. So angle 4 and angle 6 also. Those are the same side interior angles. Now, if we move just one out, okay, now if we look at angle 1 is no longer an interior angle. It's an exterior angle. We go down 1, we have 7, which is an exterior angle also. Now notice angle 1 and angle 7, they're both on the same side of the transversal. Okay, so using the same exact reasoning, we're going to say same side exterior angles. Okay, which ones are those? 1 and 7. So they're both on the same side of the transversal, and they're both exterior. So angle 1 and angle 7. And then also, if we go to the other side, it's going to be 8 and 2. So angle 8 and angle 2. Okay? Now I'm going to draw another picture real quick because I don't want it to get too cluttered. So same side interior, same side interior. If they're outside, then it's same side exterior. Okay. I'm going to draw the same picture. T, L, M, 1, 2, 3, 4, 5, 6, 7, 8. We have interior on the inside, exterior on the outside. Okay, so now I'm going to look at angle 1, and instead of going to the same side of I'm looking at angle 1 as an exterior angle, right? So instead of going to angle 7, which is on the same side, I'm going to switch over to the other side. So we're going to look at this. Now this is, you could say different, but the word we're going to say instead of different is going to be, or opposite would be alternate. Alternate means, so we're going to talk about the other side of the transversal. That's what that, so if we look at angle 1 and angle 8, those are alternate. They're exterior angles. They're alternate exterior angles. And that would be angle 1 and angle 8. Okay? Now they're not the only alternate exterior angles, because 2 is an exterior angle also. And if we start on this side, then we go to the other side here, and it'll be 7. So angle 2 and angle 7 are also alternate exterior angles. Okay? So now when we go inside, we can still do the same exact thing, but now they're no longer exterior angles, they are interior. So if we start at angle 3 and go to 6, that's going to be alternate interior angles, and that's going to be like angle 3 and angle 6. And it's also going to be like angle 4 and angle 5. Okay? So those are going to be the alternate interior angles inside, alternate exterior on the outside. So you're switching whenever it says alternate. going to the opposite side. Now the last group of problems, or the last angle pair, is something called corresponding angles. Okay, so deciding on the name course, and for corresponding angles, what we're looking at is they're not going to be angles where they're both interior or both exterior. You're going to have one of each. Okay. So you're going to have one interior, one exterior, one, and then they'll both be on the same side. Now, the way I like to think of it is in terms of its location, how you would describe it to somebody else. If I'm saying, okay, out of these four right here, I'm thinking of an angle, and if I wasn't allowed to use the numbers or the name or whatever we have here, how could I describe it to the person? Well, I would probably describe it by location. I would say it's in the upper left or the upper right, lower left. If you've ever told somebody to look for something in a drawer, like in a desk. So where do you look? Okay, well, it's in the upper left drawer or the lower right drawer. Okay, so if we look at this right here, that's upper left, right? This would be upper right, lower left. So if we have upper left up here, we're looking for upper left down here. And out of these four, 5 is the upper left. So these two right here, both using the same description, that's corresponding. Those are corresponding angles. So corresponding angles would be both upper left, both upper right, lower left, or lower right. Okay, so you got 4 different angle pairs. So angle 1 and angle 5. Okay, or angle 4 and angle 8. Angle 2 and angle 6. And then I'm running out of pins here. So we got 2 and 6, 4 and 8, 5 and 1, and then 3 and 7. So angle 3 and 7, angle 1 and 5, 4 and 8, 2 and 6. Those are all corresponding angles. Okay?